Welcome to the Deep Dive.
Great to be here.
Today, we're really digging into semiconductors, looking at where things stand around May 19th, 2025.
Yeah, lots happening.
Pulled together quite a bit. Industry news, Reuters, Globe Newswire, updates straight from Nvidia, TSMC.
And the tech press, too. Tom's Hardware, TechCrunch.
Right, plus the financial side from Barron's, FT, and analysis from places like TrendForce, Infosys.
Quite the mix.
So our mission really is to cut through the jargon. What are the key shifts in AI chips? Manufacturing, the global supply chain.
What really matters right now.
Exactly. Let's get into it.
It's definitely a fascinating moment. I mean, what strikes me from looking at all this is just the sheer speed of change.
Right.
And so much of it is being pushed by, well, AI. The demand for processing power is just huge.
Yeah.
We're seeing not just new designs, but big shifts in how and where these chips actually get made.
Okay, so let's unpack that. Maybe start with the design side. AI and chip design, Imec comes up, Luc van den Hove. They seem to have a pretty interesting vision.
Oh, absolutely. Van den Hove's point is crucial. AI changes so fast, the chips themselves need to be way more adaptable.
Adaptable how?
Well, he talks about these modular supercells. Think of them like Lego bricks for chips.
Okay.
Connected by a network on chip. So smaller, specialized units talking to each other really efficiently.
So you can kind of reconfigure the chip for different AI jobs, not just one fixed design.
Exactly. It's less like one giant brain, more like a team of specialists you can rearrange.
That sounds flexible.
It really is. And it could change how AI hardware gets developed. Faster cycles, maybe more chips tailored for specific tasks, which seems increasingly important.
And Imec isn't just, theorizing.
No, not at all. They've been leaders in things like 3D stacking building chips vertically, packing more logic and memory closer together.
Stacking them up.
Right. And the fact that big players, TSMC, Intel, are actually using these kinds of techniques now, it shows that early research paying off, real-world impact.
Okay, now this is where it gets really interesting to me. Nvidia, they're pretty dominant right now in AI GPUs.
Honestly dominant.
But they seem to be making some, strategic shifts. Jensen Huang at Computex, opening up their AI server platform. Two competitors like Qualcomm, Marvell. That feels significant.
It does, yeah. It could be maybe Nvidia seeing the need for a bigger ecosystem, or maybe getting ahead of potential regulation down the line. Hard to say for sure. But what's maybe even more striking is this Foxconn collaboration, building a massive AI factory in Taiwan.
An AI factory, what does that even mean?
It's not making widgets. It's going to use 10,000 of their best Blackwell GPUs just to help TSMC with R&D.
So using AI to design loader chips.
Yeah.
Or make them better.
Exactly. An entire huge facility just for that. Using AI to advance manufacturing itself. It's kind of meta.
That is pretty wild. And they're not stopping at the high end, right? They're also working more with Acer, Asus, Gigabyte.
Right, the Taiwanese manufacturers for high-performance desktop AI systems.
So it really looks like they want a piece of everything, from the giant data centers.
All the way down to your PC.
Yeah, a finger in every pie.
It's a very comprehensive strategy, clearly aiming to cement their position across that whole AI landscape. Which, naturally, brings us to the manufacturing side. How are these designs actually being made?
And that leads straight to TSMC, doesn't it? They're making some pretty big moves.
Big is an understatement. 9 new or upgraded facilities in 2025 alone. That's apparently the most they've ever done in a single year.
9. Wow. And they're ramping up N2, the 2-nanometer class process?
Yeah, expected H2 2025 for mass production. Fab 20, Fab 22 in Taiwan.
So what's the big leap with N2? Why is it such a big deal?
Okay, so the key technology here is GAA. Gate-all-around nanosheet transistors.
Right, GAA. Heard the term.
So traditional FinFETs, the gate controls the electron flow, like from 3 sides. Think of it like pinching a hose.
Okay.
GA, it wraps the gate all the way around the channel, 4 sides, much tighter control.
Like squeezing the hose evenly from all sides.
Exactly. Better control means less leakage, faster switching, so faster chips and lower power consumption.
Which is basically the holy grail for chip design.
Pretty much,
yeah.
Especially for AI, which is incredibly power hungry. Getting GAA into mass production this quickly, it really shows TSMC's edge in manufacturing.
Okay, but then you have Intel. They've got big ambitions too, right? Becoming number 2 in contract manufacturing by 2030.
That's the goal. Yes, a very ambitious one.
But it sounds like maybe some bumps in the road.
That's a fair way to put it. Look, building these cutting-edge fabs is incredibly complex. The delays they're facing with the big Ohio plant, the $28 billion one,
Yeah.
pushing the start date to 2030 or even later, that's a significant setback. It really highlights the challenge. I saw one analyst compare building one of these fabs to basically constructing and running a small city. Everything has to work perfectly.
A small city. Wow. Okay, so TSMC pushing ahead, Intel facing some headwinds, which brings us neatly to the geopolitical side of things.
Always a factor in this industry.
The U.S. has the Cheap PS Act, trying to bring manufacturing back. How's that playing out?
Well, the cheap PS definitely kickstarted investment. There's momentum. But if you look at the broader picture, things like proposed tariffs, trade investigations, they create uncertainty. Look at the reported delays at Samsung's plant in Texas. It shows how these bigger policy moves can ripple through and affect those domestic manufacturing goals.
So it's complicated. Industrial policy meets, well, global economics.
The very tricky balancing act.
And while the U.S. is working through that, China seems to be making strides in a really critical area, EUV lithography.
Ah, yes, EUV. The absolute cutting edge for printing chip features.
The super precise ultraviolet light machines, right? Yeah. Dominated by ASML in the Netherlands.
Correct. And the report suggesting China is making real progress on developing its own EUV systems. That's potentially huge.
How huge?
Well, if Huawei really is testing a homegrown EUV system in Dongguan, aiming for trial production maybe later this year, mass production in 2026?
That would reduce reliance on ASML.
Significantly. It would be a major step for China towards, technological self-sufficiency in this really vital area. It could reshape the whole landscape.
Okay, definitely something to watch.
Yeah.
Let's shift gears a bit to the market itself, the money side. It's already huge, but the projections.
Oh, they're staggering. Going from, $623 billion this year.
Projected, yeah.
Projected for 2025, right? To over $1 trillion by 2035.
$1 trillion, wow.
It just shows the scale. And the drivers are pretty clear, aren't they? AI everywhere, data centers expanding like crazy, cars becoming computers on wheels.
All needing more and more advanced chips.
Exactly. Even just the growth expected for this year, 2025, something like 11% year over year, pushing $700 billion.
So the momentum is strong right now.
Very strong. So for you, tracking this, it signals massive opportunities, right? But also highlights just how critical these underlying technologies are becoming to, everything.
And within that massive market, one company standing out, especially for AI, seems to be Broadcom with ASICs.
Yeah, application-specific integrated circuits, custom chips.
Right. They apparently have a huge share of the AI ASIC market.
The estimates are pretty high, yeah. 70, maybe 80% share back in 2024.
What's their angle?
They're really focused on designing these custom chips for specific big customers.
Right.
Major tech companies, cloud providers, especially for their data centers.
These tailor-made AI chips.
Exactly. And they seem well-positioned with the data center boom, especially in places like Saudi Arabia, the UAE, where there's huge investment happening.
So as AI gets more specialized, custom chips become more important, and Broadcom is right there.
That seems to be the strategy, and it puts them in a very strong position.
Okay, so let's try and pull this all together. Quick recap. We're seeing this push for AI chips that are more flexible, adaptable.
Driven by things like modular design, network on chip.
Then there's the manufacturing race, with TSMC really pushing the boundary with 2-nanometer GAA tech.
While others like Intel face the sheer difficulty of scaling up so fast.
And overlaying all that are these geopolitical currents, right? U.S. incentives versus trade frictions, China's potential EUV breakthrough.
Shifting that global map.
And finally, this massive market growth, just accelerating, powered largely by AI demand, benefiting players like Nvidia and Broadcom in different ways.
It really is an incredibly dynamic picture right now. High stakes, lots of competition.
It definitely is.
And, reflecting on all this, the speed of innovation, these global shifts, it raises a bigger question, doesn't it, for you to think about?
Yes.
Well, clearly, semiconductors are driving our tech future, no doubt. But these developments also force us to think about things like technological sovereignty. Who controls the core tech? And how does that shift the balance of, global economic power? As this acceleration continues, what does it really mean for different countries and, for the future of technology itself? Where is all this heading? Big picture.